Hi students, how are you all? Welcome to one more amazing session from Infinity Lane. This is Suresh, Faculty of Chemistry from Infinity Lane. Today we are going to discuss about electrochemistry. You know, in the NEET examination, without a question from this electrochemistry, you don't expect this paper. Definitely you are going to get one question based on this electrochemistry. So 4 marks will be yours at the end of this topic. So please confirm you are all able to hear me. Just give a confirmation you can hear me, right? That's fine. Those who are online, please like the session. And because we want to take you some exciting things out right now, along with the concept as well as some promotions. So let's see, it is all about the Atreya. So this is the India's largest powerful program for your NEET repeaters. You all know it is 2025 paper is going to be very good and standard, and physics is just like a slapper like anything. So yes, physics is a difficult topic for you all guys. Not only you, for all students preparing for NEET examination. To avoid that, I want to say Infinity Lane by Chaitanya Academy want to take physics honors and introducing you Atreya P Square CB. And this is a program will make you to transform from I didn't do to I will do it. Crack your NEET examination, introducing Atreya, India's most powerful NEET repeaters program, which includes P Square CB, physics twice a day, chemistry and biology, and it is proved a lot and students did well. And also you see in this program you're going to see various things, just like particulars. The course design, I just want to say, it is started May 23rd. And a long ago, you don't worry, every week a new batch is going to be introduced. So in that you can enroll. In the description box, the link is available. You just click that link and enroll yourself so that you can experience the awesome journey of NEET preparation by Atreya. And the classes are from Monday to Saturday. And each class is 90 minutes. And 3 classes per day, and in that you have 2 concept classes and 1 practice sessions, and 18 classes per week. So the program is designed in such a way that you won't be having any kind of pressure on you, but automatically the program is going to drive you towards your result. You want to enter into your dream medical college, enroll Atreya, and here want to say interactive live classes. In that program 465 live classes are being given, and also 240 DPPs, and there will be 120 dedicated practice sessions. You see, the concept classes, interactive concept classes include practice sessions. You know one thing, these practice sessions, this is very, very important. No online platform in India is introducing this. Just in the practice session, just 20 to 20 students in that batch. In that batch, if you have very limited, if you go with the other platforms, you may be one student among hundreds, but here just 20 to 20 students, 25 students will be in that batch. So that you will be having a great opportunity to interact with your faculty, and customized doubt resolutions can be possible. You can directly have a voice interface with your faculty. So that is going to be a super awesome criteria for your NEET preparation. And also you see notes will be given at the end of the session. So you need not have to prepare any kind of notes, and coverage of the syllabus 11th to 12th syllabus will be covered up to the NEET examination. Right beta? And link is available, description box mein hai. Everybody click it and just enjoy this program. And also I just want to give you a very good thing, very, very good thing, and India's largest scholarship examination. Why this is a score examination? This score examination is intended for any student from grade 3 to grade 11. And you may be a student of Sri Chaitanya, or you may not be a student. You may be some other government college or private college, that doesn't matter, but still you are eligible to write. Just simply, link is available in the description box, and click it and do your best for your examination. So India's largest scholarship examination score. Why this score? Sri Chaitanya Academy want to just identify the bright minds in India. So we are in the hunt of bright minds. So you just be one of these, and you see exciting prizes are there. Really it is going to be an awesome thing. Here see 2.5 crore of cash rewards directly will be given bacho. Is very simple. And 350 crore worth of scholarships will be given to you as a presentation. That's why I say it is India's largest scholarship examination. And in the description box you just see, click it and you can just enter your details and you can just enroll it. Say simple, very nice. And you can see exciting. You want to go to NASA? Have you ever dreamed? Yes, we will take you. If you really do well, and a group of students, we are planning to take them to the NASA. And you can see the space shuttles and all, everything. A NASA trip is going to be an awesome experience in your life. Never forget. And you will be given exciting gadgets like a tablet, and you will be having a laptops, so that where you can just go through your online classes and surfing and ChatGPT, everything you can do it. And also up to 100% scholarship wherever and whatever the program you just opt for it, and we are ready to give it up to 100% scholarship up to the level of benchmark for the deserved student. So while it in the link description box is given, you just click it and write the score examination. All the best. You know the score examination, September 28th is the exam date. So exam is conducted twice, September 28th and October 12th. And registrations are open, and the test may be at online at offline centers, and you can go online and sit at home and you can write the examination, or otherwise go to any nearby Sri Chaitanya academies, and there also you can write the examination. Definitely you will be having that feel. So all the best. God bless you, my dear students. So score promotion is over. And one more important thing I just want to say, whatever examination you are preparing, it is required to know what you are doing. If required, you just ask any one of the students who did well and the toppers of the Neet or any kind of examination who already secured medical seats. Ask them, they prepared well and you also preparing well. All the best. But the thing is, they will say one thing. What is that? Whenever you are writing some examination, it is required to understand where exactly you stand and what is your improvement areas, and everything can be done by using a proper assessment platform. So Sri Chaitanya Academy by Infinity Learn introducing Neet test series. In this Neet test series, it is an ultimate key to your Neet success. आप जो कर रहे हैं ना, आपको पता होना चाहिए आप कैसे कर रहा हूँ. For that you need a Neet preparation test series. We designed this test series in 3 different segments, like 11th standard one segment, 12th standard one segment, and repeaters को एक segment. And you just see it is based on the latest NTA examination pattern, and it gives you a real-time simulation that you are writing your Neet examination. Okay, and when you go and write your Neet examination, and you feel as if this is the same simulation you got it, so you won't have any kind of nervousness, you know. And also it is prepared by the top most Neet faculties with our team. And while the link is there in the description box, click it and just enroll into your Neet test series. And हाँ, और एक बात है, if you write YouTube 30 of coupon code, if you enter it, automatically you will be having 30% discount. So my promotion is over. So shall we start a class about electrochemistry? So electrochemistry, I want to make it easy. Everybody knows the concept about the electrochemistry. There are 2 criteria. If you know it, well and good. If you don't know, you learn it. And what is the benefit that you are going to get in today's class? I will make it more elaborate and tricky methods, right? So those students who are online, please like the session. So when you click the like button, I will be knowing the number of likes, so that you see the session josh bad jata. Okay, bachcho, get ready. Thumbs up and fire emoji, everybody. Thumbs up and fire emoji so that we can start the class. Now it's all about the electrochemistry. In this electrochemistry, in today's class, we will discuss about most of the things about the voltaic cell, okay, and types of electrode half cells, and also standard electrode potentials, and also some numericals. After that, electrochemical series also we will discuss. And moving into the details, this is a live interactive session, bachcho. I want you to be interactive with me so that you can use the chat box and you can discuss with me any kind of doubt, so that we will be having a two-way communication. Dear students, this class is not all about a radio telecast session. You want to have this kind of sessions, you can go to the any coaching center and you pay huge amount of money. You don't have to pay anything for us. Simply sit at home and enjoy the class, and take a pen and paper and write a noteworthy points. If questions are coming, do along with me, and I'm going to give you some tricks and tips, and a big complicated concept will be explained in a simplest way. Get ready for that. So my dear students, let us go into the voltaic cell. I'm requesting you, this class is completely free of cost, so please like the session so that we can have a kind of discussion. Hi students, come on. Let's see, what is a voltaic cell? The electrochemical cell, where a chemical reactions are converted into electrical energy, and this is a spontaneous redox reaction, where a device in which the electrical energy is generated by performing redox reactions, that is called galvanic cell. This is used called as voltaic cell or electrochemical cell. For that, according to the thermodynamics, my dear students, delta G is equal to negative. So the process is going to be spontaneous. It is going to be spontaneous. That is the important. So delta G negative होना चाहिए. Thermodynamics का हिसाब से अगर delta G 0 होगा ना तो the process is at equilibrium. Delta G is negative, the process is going to be spontaneous. Delta G is positive, the process is going to be non-spontaneous. These are the noteworthy points. We are applying this delta G values and moving ahead towards this process of the electrochemical cells. Now you can see this is a zinc sulfate is taken in a weaker separate container, and another container copper sulfate is taken. Okay, and in that zinc plate is immersed and other container copper plate is immersed, and that is connected to an external bulb or any voltmeter. Now what is happening in this process? Zinc is a solid, actually zinc is a solid metal here. Zinc is a solid. So you try to see this animation, and this is a copper. Now the zinc, everybody, it's an awesome slide, and zinc is going to lose electron. You know, loss of electron is called oxidation, and gain of electron is called reduction. My dear students, this is important. So we are most connected with an oxidation and reduction over here. So zinc is a metal over here, zinc is a solid, loses 2 electrons and become zinc 2 plus. So that zinc 2 plus that is formed in this is coming out. So that zinc 2 plus is coming out. So this process is called oxidation process. So the electrons that is lost by the zinc, the electrons lost by the zinc is going and moving over here by external electric current. Okay, that is a external circuit. So what I mean to say, electrons are moving in this way. Are you getting or not? So these electrons are trapped here, coming to the copper side. Got it? When it coming to the copper side, what is happening? This copper is already have copper sulfate, no? So that copper sulfate that is already present here in the solution, copper 2 plus in the aqueous solution, going to take those 2 electrons. So they are going to take this electron, so that copper 2 plus become a copper here. So this is a gain of electron process is called as a reduction process, understand. So oxidation process and the reduction process simultaneously taking place, and it is a driving force, and it is called as a spontaneous redox reaction. And in respective to this, current is moving in this way. Direction of current flow is opposite to the direction of electron flow. That is a convention in the physics, and we have to follow the actual thing is have. Of course, this is a salt bridge, and let us discuss about the salt bridge. Salt bridge is U-shaped glass tube where like potassium nitrate or any inert solvent is made. To make it standard and static, we will make this into a semi-solid substance by using agar-agar gel. So, which agar-agar is a gelatinous material that is made here to avoid the salt is directly pouring down. So that whenever zinc is oxidized and zinc plus is released, so positive charge बढ़ जाता, ये सेल में positive charge बढ़ जाता, and electrons are coming and dropping here, ये सेल में negative charge बढ़ जाता. So सेल न्यूट्रलिटी रखने के लिए KNO3 में जो NO3 माइनस है ना, ये नीचे आके जिंक 2 प्लस को पकड़ के जिंक नाइट्रेट बनना है. सो न्यूट्रलाइजेशन टेक्स प्लेस. आर यू गेटिंग और नॉट? क्लियर बच्चों? And here potassium plus is coming and neutralizing the electrons over there. Okay, you are going to get potassium sulfate, and it also complete the circuit over here. It also complete the circuit over here. You can see the circuit is being completed, conductivity. Are you getting or not? This is very, very important. This is very, very important. Any doubt? But so in the entire electrochemistry, I just want to categorize into 4 parts. One is a galvanic cell or voltaic cell. That is one parameter, where it is included with the Nernst equation, electrochemical series and applications of this. So this is one segment we are going to get a question. Another segment you are going to see the electrolysis, that is the Faraday's laws also included there. That is another segment. One is a galvanic cell, another one is electrolysis, and the third one is conductance and cold rush law is the third segment. And the fourth segment is corrosion and rusting and batteries and everything is the fourth segment. Any one of the segment is taken to the consideration to grab one question, and this is the one where it is quantitatively related to stoichiometric calculations, and it also connected to the redox reactions in the grade 11, and this electrochemistry is the topic. It's actually grade 12 topic. But whenever you are doing something, you need to have a clear picture आप क्या कर रहा हूँ, उसमें आपको क्या चाहिए इसके एग्जामिनेशन का हिसाब से. Everything has to be discussed here. Please stay tuned in the class. Those who are online, I request you guys, please like the session, share with your friends, and subscribe to Infinity Land YouTube channel, and use the chat box generously, and you can talk to me and you can get the concept without any ambiguities. You can open the book and you can study. But उसमें कुछ है जैसे topics हैं, like why zinc is losing electron and copper is gaining electron. Okay, that may be given in a different explanation, but here I just want to give you a crystal clear explanation in a shortcut form. So dear students, is my voice is audible here? Is my voice is audible here? Yes. Now let us talk about the details about this. So zinc and the copper electrodes joined externally by a wire. So zinc sulfate and copper sulfate is taken here. In that zinc plate is immersed. This is your zinc plate and this is your copper plate. You know? See the animation, how beautifully it is connected. And there is a salt bridge over here. I already mentioned what is a salt bridge. And the electrons are moving from here to here. You can see the electrons are moving from here to here. And this is an animated form of this. At the end, you can see after some time, the zinc mass is decreased because zinc is oxidized. and the copper mass is increased because the copper is deposited, and you can see the electrodes are immersed, and these electrodes, zinc and copper, connected by using a external wire, and this external wire and is connected to a voltmeter and a salt bridge. After some time, what happened? The zinc is dissolving, the electrons are going in that way, and copper is depositing. You can see copper is depositing. As the copper is deposited, zinc is dissolved. You can see mass of the zinc is decreased and mass of the copper is increased. You understand? Clear? You understand? Okay. Now you can see here copper and zinc. Copper is a cathode and zinc is an anode. Here there is a flow of electric current through external circuit. That's why it is moving in that way. And zinc rod loses its mass while the copper rod gains its mass. And you can see the concentration of zinc sulfate increases and the concentration of copper sulfate decreases. Understand? Clear, bacho? Happy? Any doubt? And the solution in both compartments remain electrically neutral because we are using salt bridge over there. Salt bridge maintains the electrical neutrality, right? Why? So this kind of demonstration and this kind of animated pictures can give you a better picture. Bacho who are online, please like the session. Okay. Now, the voltaic cell, the chemical reactions in the galvanic cell. Take a pen and paper, write the noteworthy points. Actually, left hand side, what you had, you just want to say a simple picture over here, zinc and copper. Okay, so we have a zinc sulfate, zinc rod, and we have a copper rod, and both are connected by using a voltmeter. And zinc sulfate is taken and copper sulfate is taken, and it is connected by using a salt bridge over here. And when you see the loss of electron takes place, this is called anode. Always anode oxidation takes place and cathode reduction takes place. Anode oxidation takes place. Hi Soumya, how are you? You came late today, why? So, left hand side oxidation half cell is written, always the cell, the electrode where oxidation taking place is called anode. That's a fundamental rule. And zinc is converted into zinc 2 plus, it's an oxidation process. That has to be written as LHS. That has to be written in LHS. Left hand side anode is written and the right hand side cathode is written according to the rule given by the NCERT and IUPAC. Okay, bacho? And the electrodes from the zinc electrode flow, the electrons from the zinc is converted transmitted from here to here, so that it is coming to the copper. So that at cathode, why no problem beta. So at right hand side cathode is written, so the electrode where reduction takes place is called cathode. So the copper 2 plus takes 2 electron become a copper. Okay. So always remember right hand side anode is written and left hand side, right hand side cathode is written, left hand side anode is written, and cathode and anode are separated by a salt bridge. And these are the reactions, and the voltage is going to be shown here, that is 1.1 volt. The galvanometer, if you keep it, and the galvanometer is going to show the direction in this way. And also you see the net overall reaction is going to be zinc plus copper 2 plus gives rise copper plus zinc 2 plus. So as a result of this, zinc concentration बढ़ जाता, solution में copper concentration will decrease. बच्चों, hope you understand. Now let us see in the voltaic cell, the salt bridge. What is a salt bridge? You can see this is a zinc and this is your copper. zinc is dissolving to give a zinc 2 plus, and copper is depositing as a copper. So this is your anode negative charged and this is your cathode positive charged. And you say anode is shown with the negative charge over here, cathode is shown here with the positive charge over here. So anode and cathode are not named according to their positive charge or a negative charge. Anode and cathode are named for anything in the electrochemistry in terms of oxidation and reduction. So the electrode where oxidation takes place is called as anode. The electrode where reduction takes place is called cathode. Understand? Clear? Wonderful. So this is a salt bridge. So salt bridge is a U-shaped glass tube where it is filled with inert salt like KCl you can use and KNO3 you can use, और you can use any inert salt. Inert salt का मतलब क्या, जो salt है ये जिंक सल्फेट कॉपर सल्फेट से रिएक्ट नहीं होना चाहिए, and it should be chemically inert. And you know the ionic mobility of the cation should be equal to ionic mobility of anion. So I mean to the speed of the cation and the speed of the anion should be nearly same. Then only it can maintain electrical neutrality effectively. And you know, so in this you see a salt bridge is a U-shaped tube filled with strong electrolytes such as KCl, NaCl, KNO3 and so kind of things. So it must be inert towards the chemicals used in the electrochemical cells. Then only you can use, otherwise the reaction इसका कुछ चालू होना तो क्या करूँ मैं, so reaction उल्टा उल्टा हो जाएगा, so the cell won't work. And you know the cations and anions of the electrolyte of the salt bridge must have the same speed. ये वाला में क्या चल रहा है, ये lambda है ना, ionic mobility, speed of the ions. And also the salt bridge, the electrolytes are held as gel like agar agar. You know just jelly chocolate, उसमें क्या होता है, सिर्फ शुगर, कलर, फ्लेवर एंड agar agar, so that it is a jelly like material. Similarly that jelly is made here, but bad news, sugar is not added and color is not added, just inert electrode is added. You understand? Clear? Now मैं एक सवाल पूछना चाहता हूँ सौम्या. I want to ask you, what happens if the salt bridge is removed? What happens if the salt bridge is removed? I want to hear from you. What happens if salt bridge is removed? Quickly you tell me. Think and you tell me. Anything you just say. Whatever you feel it. Soumya, if salt bridge is removed, the galvanic cell or a voltaic cell stop working. It will stop working and the circuit is disconnected. And somebody asks you what is the role of salt bridge. Role number 1, it completes the circuit, Soumya, and it maintain electrical neutrality and it physically separate anionic compartment and a cationic compartment, anodic compartment and cathodic compartment, and it prevents liquid junction potentials. So the interface of this metal and metal ion बीच में कुछ electronic potential develop होगा and it prevents the liquid junction potential. Why I am telling you this? Role of salt bridge, NEET examination में एक क्वेश्चन पूछना का ज़्यादा संभावना होगा. Which of the following is true as far as this salt bridge is concerned? And you have a very valid point here. This is very valid point and you can see based on this you can write. Got it, Soumya? Hope you understood. Now I just want to take you to more details about the voltaic cell. Now you see this is the voltaic cell. थोड़ा बड़ा दिख रहा है. So voltaic cell or a galvanic cell. It is supposed to be spontaneous redox reaction. Spontaneous redox reaction. And जिसका डेल्टा जी सौम्य पॉजिटिव हो सकता है, नेगेटिव हो सकता है, जीरो हो सकता है. बोलिए इसका डेल्टा जी क्या हो? हमेशा नेगेटिव होने का कम कंडीशन है ताकि ये गैल्वानिक सेल काम करता. नाउ आई जस्ट वांट टू यूज ए बैटरी ओवर हियर. लेट मी कनेक्ट ए बैटरी ओवर हियर. Okay, I connected a battery. Sir, external EMF देता है ना? Yes. And you know it is going to be for the galvanic cell 1.1 volt. So standard galvanic cell, right? Now see the applications of this. If external EMF is equal to 1.1 volt. So what happened? This is going to give you 1.1 volt, है ना? So if it is given 1.1 volt, this is your driving force and this is going to be opposing force. So I want to say here, driving force हमारा galvanic cell का है and opposing force जो external EMF का है, ताकि इसका driving force is equal to opposing force. Therefore, both are getting cancelled. When you see the both are getting cancelled, it is going to be delta G is going to be 0, cell is at equilibrium. Cell is at equilibrium. These are the conditions. NEET examination में ऐसा logic आपका पता होना चाहिए. Otherwise, simply whenever you by heart a formula and go ahead, okay, and you can't do it. Are you getting or not? Clear? Any doubt? And और एक कंडीशन लेना चाहता हूँ, इसका जो डेल्टा जी है ना, नेगेटिव है, नेगेटिव होना चाहिए ये काम करने के लिए. एंड अगले बार हमारा जो ये बैटरी है ना, दिस इज द बैटरी. I just want to use external EMF, and this external EMF battery I want to make it greater than 1.1 volt. Okay, greater than 1.1 volt. So what happened? Soumya, tell me what happened. So iska external EMF is greater than 1.1 volt, है ना? If it is greater than 1.1 volt, so that EMF, so this is opposing force. This opposing force is more as compared to the driving force, है ना? So opposing force is greater than driving force. So that what happened, the current, the electricity want to go into the compounds. So as a result of that, compound is going to be decomposed. When the compound is decomposed, that process is called non-spontaneous process, and it is going to be an electrolysis process. So the cell works as electrolytic cell. सेल वर्क्स एज इलेक्ट्रोलाइटिक सेल. इसका डेल्टा जी नॉन स्पॉन्टेनियस होगा, डेल्टा जी इज गोइंग टू बी पॉजिटिव. सो these are the various classes of understanding the galvanic cell. Simply galvanic cell, everybody knows zinc and copper, zinc rod is immersed, copper rod is immersed, so that electron zinc से copper तक आ रहा है ना, so that it is going to zinc is disappearing and copper is getting its mass on it. So एक सार फिर okay. Now उसमें क्या हो रहा है ना, you are using a battery. This is Soumya, this is a battery, है ना? ये battery हैज़ ए पोटेंशियल, सो इसका पोटेंशियल मान के चलो ये कंडीशन में 1.1 वोल्ट से ज़्यादा आ रहा है ना, बट दिस गैल्वानिक सेल हैज़ मैक्सिमम 1.1 एट स्टैंडर्ड कंडीशंस। ये ड्राइविंग फोर्स 1.1 है, अपोजिंग फोर्स 1.1 से ज़्यादा है, मान लो 2 वोल्ट होगा, सो अपोजिंग फोर्स इज गोइंग टू पुट डाउन दिस, सो दैट अपोजिंग फोर्स जीत गया ड्राइविंग फोर्स से। ड्राइविंग फोर्स हमारा गैल्वानिक सेल का है, सो व्हाट हैपन, ये ड्राइविंग फोर्स नहीं है, अपोजिंग फोर्स जीत गया, सो these electrons are going into this. So whenever electrons comes by a flow into the compound, this compound is started decomposing. That process is called electrolysis process. अभी जो फिलहाल जो वोल्टाइक सेल है ना, गैल्वानिक सेल, वोल्टाइक सेल, everything is same. So this is not generating correct, but it is going to start decomposing, so it wanted to say it is an electrolytic cell. So whenever driving force is less, opposing force is more, it is going to start behaving like a electrochemical cell. Whenever electrolytic cell, it is going to be delta G is going to be positive. Hope you understand, Soumya. Clear? Entropy is negative, definitely Muhammad Arfan. Yes, entropy is actually a different criteria. Okay, entropy is going to be positive in this way. Entropy is going to be positive. So the total entropy is completely different. In the galvanic cell, jo hai na, if it is a galvanic cell, here entropy is going to be increased, here entropy is going to be decreased. Okay, the overall system entropy is completely different. There are two systems in a closed way. So is a part of a system, is a part of a system. Of course, both are conducted here. Okay, so we talk in terms of electrons, and we'll see the voltaic cell. We'll see the voltaic cell. The third condition. Can you guess what is the third condition, बच्चों? Mohammad Afan, how are you? एक बार like button मारो यार. Those who are online, please press the like button. Please press the like button. Now, third condition. Here the same thing here. When you see, I just want to say this is a battery where battery is connected with less than 1.1 volt. Less than 1.1 volt. So it is less than 1.1 volt. Right? Muhammad Afan, I am fine, thank you. So whenever this is giving 1.1 volt and it is applied, external EMF is applied less than 1.1, so that opposing force itna hai and driving force itna hai. So as a result of this, opposing force is less, opposing force is less than driving force. Opposing force is less than driving force. So driving force jeet gaya. So that what happened? This is going to still acting as a galvanic cell. So cell behaves as galvanic cell. When the cell behaves as a galvanic cell, delta G is going to be negative. You understand? There are three conditions I just want to show. Again, or ek baar, you can see here, when external EMF is equal to 1.1 volt, so driving force is equal to opposing force, delta G is equal to 0, and the cell is at equilibrium. And the next condition, you see, when external EMF is greater than 1.1 volts, you can say it is going to be opposing force jeet gaya driving force se. So that it is going to be opposing force ka tamasha zyada chal rahe hai na. So that it is going to be, cell works as electrolytic cell, delta G is going to be positive. And you can see when external EMF is less than 1.1 volt, So this is opposing force and the driving force is more than opposing force. If that is the case, you can see delta G is still negative. So there are three conditions: delta G can be 0, delta G can be positive, delta G can be negative. जब तक डेल्टा जी नेगेटिव तक चल रहे हैं ना, ये सेल इलेक्ट्रोकेमिकल सेल गैल्वानिक सेल का जैसे बिहेव कर रहे हैं, दैट इज द कंडीशन. डेल्टा जी जीरो होगा तो ना इक्विलिब्रियम है, जब इक्विलिब्रियम है काम नहीं चलेगा. दिस कैन नॉट बी ए सोर्स ऑफ एक्सटर्नल, it cannot be source of the current for us. And you know, if whenever delta G is going to be positive now, it can no more a galvanic cell, it is going to be the electrolytic cell. Understand? So this is about the voltaic cell, and I just want to line notation of electrochemical cell. Whenever you see the question from the electrochemistry, first of all you just freak out, you don't understand what exactly the question is saying for us, because some lines are shown. So no worries, I am going to help you out of this. And when you see the galvanic cell is written always LHS, anode is written RHS, cathode is written. Anode and cathode are separated by salt bridge, can be shown by a two vertical lines, Muhammad Afan. And you can see notation of anode is written from the left and that of cathode is written on the right. And also zinc and zinc 2+, a metal interface is there. Copper 2+ and copper, a metal interface is there. And this is your anode. This is your anode, क्योंकि ये LHS में लिख रहा है ना. And this is your cathode, and it is written in RHS है ना. And it is an anode, you can see zinc is converted into zinc 2+. You have to write it like that. And the copper cathode is converted, copper 2+ is converted into copper. Okay, and you can see the concentration of the zinc sulfate is written here. Let us say it is a C1, and it is a copper 2+ is written as a C2, and it is concentration, say it could be 0.1 or 0.001. So, and the cathode and anode separated by two vertical lines, that two vertical lines indicates it's a salt bridge. When an external EMF greater than 1.1 volt applied to a Daniel cell, the current will flow into the zinc to copper. No, the current will flow from copper to zinc. You want to say current, okay, electrons will flow from in the opposite direction. So current will flow from zinc to copper. Okay, yes, what you said is correct. So in terms of chemistry, we flow of electrons we consider. In the physics, if the electrons in this way, current will be in this opposite way. Okay, so your argument in terms of current will be the same. What you said is correct. Afan, thanks for your interaction here. Those students who are online, please like the session, Okay, right. Soumya, you are not asking any doubts. Soumya, आपका तरफ से doubts आ रहे नहीं? Okay, anyways, I am really enjoying here. The students are really awesome, and they are asking academic doubts, and I am very happy. Here you can see C1 and C2 are the molarities of zinc sulfate and copper sulfate, or zinc nitrate and copper nitrate, whatever it may be. And you can see a single vertical line or a comma indicates here, single vertical line or a comma indicates the change in the state of a phase. Zinc is a solid, zinc 2+ is an aqueous, copper 2+ is an aqueous, zinc is a solid. Okay, state is changed. Okay, now a double vertical line is used to indicate salt bridge between two half cells. So this is an oxidation half cell, and this is a reduction half cell, and oxidation half cell and reduction half cell are separated by two vertical lines. Understand? And also, if gaseous substances are there, you can use the pressures instead of the molarities, the same. So the pressure of the gaseous substance can also be shown here. So representation of hydrogen, and you can see PTH2 P1 HCl CO2 PT, and you are going to see platinum is the electrode, hydrogen is the gas, इसका pressure है, and hydrogen chloride इसका concentration है C, and oxygen and pressure of the oxygen and the PT electrode. So that is a normal hydrogen electrode का representation भी हो सकता. Okay, like that you understand what exactly it wanted to show. And you can see P1 and P2 are the pressures of hydrogen and oxygen respectively. HCl solution with the concentration of C. For normal hydrogen electrode, concentration of C for the normal hydrogen electrode, here it is 1 molar, and the pressure of the hydrogen is going to be 1 bar or 1 atm are taken. Okay, afan. And you can say single electrode potential, that's very important. मेरा question है कि whenever you use here, I have a question all the way. Okay, let us see. This is the case where why the electron is going away from the zinc to copper. If you have that question with you, you will try to understand what is the electrochemistry basis. So always you see, electron always move from high potential to low potential. So zinc has high electronic potential as compared to the copper. That is the reason why electrons are moving from zinc to copper. Fantastic, fantastic. So जिसे जिंक का कॉपर से कंपेयर करने तो इलेक्ट्रॉन देने का संभावना ज्यादा होता है. जैसे कि आपका कॉपर है, जिंक के सामने कॉपर का इलेक्ट्रॉनिक लेने का संभावना होता है. सो ये क्यों लेते हैं, ये क्यों देता है. इसका जो इलेक्ट्रॉन का पोटेंशियल इसका ज़्यादा है, इलेक्ट्रॉन का पोटेंशियल इसका कम है. ओके, ये दोनों का ये अंतर है ना, ये निकाल के 1.1 दिखा दे रहे हैं. दैट इज द वोल्ट मीटर का वैल्यू. एंड मैं क्या बोलना चाहता हूं, जैसे आप जिंक सॉलिड इमर्स्ड इन जिंक सल्फेट. सो ये मेटल एंड द मेटल आयन, ये दोनों का बीच में जो इंटरफेस है ना, या इंटरफेस में थोड़ा सा इलेक्ट्रॉनिक पोटेंशियल खुद डेवलप होता है. दैट इज कॉल्ड सिंगल इलेक्ट्रोड पोटेंशियल, and we will be discussing about the single electrode potential. So single electrodes are two types. One is a metal electrode, non-metal electrode. Types of electrode half cells you see. Metal electrode जैसे आपका copper immersed in copper sulfate, zinc immersed in zinc sulfate, है ना बेटा. So when a single electrode potential, non-metal, when a metal is interfaced with a non-metal ion like H plus is immersed. So platinum is immersed in HCl solution. That is going to be non-metal electrode. Okay, so why the potential is discussed? So I mean to say, when a metal is immersed in its ion, so the metal is going to go, can come out, can go in by transaction of the electrons. So electronic का हिसाब से थोड़ा सा दोनों का बीच में कुछ अंतर होगा. That difference, that field is expressed in terms of electrode potential, एक single electrode का. At 298 Kelvin at 1 atm pressure, at 1 molar concentration, that is called standard electrode potential. So E naught is called as a standard electrode potential. You know, it is impossible to measure the standard electrode potential, but the difference between these two electrode potentials can be measured. That is called voltage, is the potential difference. That is called potential difference. And I want to say, single electrode potential, the electrical potential difference at the between the metal and its ions is called electrode potential or single electrode potential. Bachcho, this single electrode potential can be measured by using a standard one. Absolute value you cannot measure. So single electrode potential depends upon the various factors. NEET examination में आप कर सकते हैं. It depends on nature of the metal or the nature of the non-metal, है ना? Right. Afan and Soumya, please ask us. And also concentration of the electrolyte and also temperature of the electrolytic solution and also pressure of the gas in case of gaseous system is there, and number of electrons involved per atom. Hi Soumya. So the standard electrode potential of hydrogen is 0 beta. Soumya, it is 0. It is arbitrarily taken as a 0. And these are the various factors that are emphasized to influence the electrode potential. If it is at a standard case, 298 Kelvin and 1 bar pressure or 1 atm pressure, these are the standard conditions. Standard electrode potential is written as E naught. These are of two types, standard reduction potential and standard oxidation potential. जो process है ना, that is a, you can say E naught of zinc 2 plus and zinc is said to be standard reduction potential, because this is a reduction process. So this is called standard reduction potential. Okay, and you see E naught of zinc becomes zinc 2 plus, and this is called the process of oxidation. This is what is called as a process of oxidation. When experimentally measured, it is going to be 0.76 volts. Please don't memorize these values. Some may don't memorize. In the examination, it will be given. And its experimental value is going to be 0.76 volts. Array, magnitude is same. बच्चों, a magnitude is same. And और एक example आपको दिखाना चाहता हूँ. You see E naught value for copper 2 plus, and the copper is going to be plus 0.34. So 2 plus becomes 0. So it is a reduction process, standard reduction potential, SRP. So standard reduction potential means the electrode potential for the reduction process. Standard oxidation potential means the electrode potential value for oxidation process. Okay, exactly 0.34 beta. And E naught value of this copper become copper 2 plus is going to be minus 0.34 volts. Don't say it is always oxidation potential negative हो सकता है, reduction potential positive हो सकता है, ऐसा rule नहीं है. लेकिन अगर ऑक्सीडेशन पोटेंशियल नेगेटिव होगा तो रिडक्शन पोटेंशियल पॉजिटिव हो सकता है, एंड वाइस वर्सा. सो आई जस्ट वांट टू से एस आर पी वैल्यू is equal to minus SOP value, their magnitude is going to be the same. You understand? Clear? This is the key point. This is the key point. Right? मैं क्या बोलना चाहता हूँ, और एक कॉपर 2 plus takes 2 electron, becomes a copper, and E naught value is going to be plus 3.4 होगा तो होना. When you reverse this equation, अगर एक क्वेश्चन, you see copper gives rise copper 2 plus and copper and electron. And for this E naught value कितना हो सकता है सौम्या, आप बोलो सौम्या, इसका E naught कितना होगा सौम्या? I want to know. Electrode potential of half cell depend on these 5 points. सौम्या 5 points में depend करता. ओके, इसका वैल्यू कितना होगा? इतना ही होता है मैग्नीट्यूड, लेकिन इसका अगर यहाँ पर माइनस होगा ना तो प्लस होता है, प्लस है ना तो माइनस होता है. 0.34 वोल्ट होगा. गॉट इट मोहम्मद अफान? दैट्स गुड. होप यू आर अंडरस्टैंडिंग द कॉन्सेप्ट. दोज हू आर ऑनलाइन, प्लीज लाइक द बटन, and please like this session, share with your friends. इन लोगों को भी फायदा होना चाहिए. Subscribe to Infinity Lane YouTube channel. When you subscribe and press the bell button, these sessions when are going to happen is going to give a notification to you, and you will be in the journey of NEET examination. Soumya, fine. Now बच्चों, here standard electrode potential at standard condition आपका 25 degree centigrade temperature, 298 Kelvin and 1 bar pressure or 1 atm pressure, both दोनों बराबर है. And by using ions in the unit concentration, whenever concentration molarity is going to be 1 unit, is known as standard electrode potential. For a single electrode, standard reduction potential is equal to minus standard oxidation potential. We already discussed it, right? And also zinc 2 plus takes 2 electron, gives rise zinc. The SRP value is minus 0.76 volts beta. And उल्टा कर दो, zinc 2 plus देके 2 electron निकाल रहे. So this is an oxidation process. Loss of electron is an oxidation, gain of electron is a reduction. जो ऑक्सीडेशन प्रोसेस है माइनस 0.76 है एंड रिडक्शन प्रोसेस है प्लस 0.76 होगा. दैट्स वेरी गुड. एंड ऑल्सो आई वांट टू हैव a couple of questions before we just conclude. Daniel cell, अरे Daniel cell, voltaic cell, electrochemical cell, galvanic cell, same, synonymous. Okay, in a Daniel cell the process occurs at anode. Anode कैसे बोल सकता हूं? जहां पर ऑक्सीडेशन हो रहा है ना, that is anode. What is anode? The electrode where oxidation takes place is called anode. Anode आपको कैसे पता चलेगा? जहां पर electron loss of electron is called oxidation. Now third option, often 2 electrons taken, so it is a reduction process. So this cannot be. It is going to be, अरे Daniel cell में copper नहीं होगा, ये reaction असंभव है ना? Copper is getting reduced actually. Zinc copper 2 plus zinc 2 plus and copper. Zinc 2. अरे option 4. This is overall redox. Overall redox reaction. That's a trap, Muhammad. That's a trap actually. And you said option 3 and eventually changed your option to 4. So you have to be stringent and confident when you write the NEET examination, because once you taken the first decision na, that you lock it. Once you lock it, hare, you are a very good student, you know the answer, but you are trapped with the options. So that is a disaster. Bachcho, if you don't know the answer, if you don't answer it, if you can't answer it, kuch problem nahi hoga, you don't deserve it. But you are such a nice person, you are a hardworking student, you are doing good and you prepared well and you can do it, you know the answer, but options पकड़ने का वक्त में आपको ट्रैप में अटक गया. That is going to be disastrous, and 25 to 30% of the students are trapped with the options. So firstly I thought it is asking overall reaction. वो ये मैं खुद बोल रहा है ना, ये trap है. Okay, it's a trap. You understand? So a trap का वजह से डर बढ़ जाता. Now you are very free, you have given so many answers of fun. Once you come to know it's a trap, अगले जो क्वेश्चंस आता है ना, ये ट्रैप के वजह से आपको थोड़ा सा हेजिटेशन भी आता है ना? You understood? No, 100% I am confident that you understood and you are such a nice student. But अगले क्वेश्चन देखो, answer, yes, it is option 4. If you see the next coming questions, no, you will be having a feel of the previous question and you implement it here. And I want to know the answer from this question. Afan and Soumya, try to do this saturated solution of KNO3 is used to construct salt bed because come on, make it fast. Velocity of K plus is greater than that of NO3 minus. greater, NO3 greater than K, and the velocity of K plus and NO3 are nearly the same. Soumya, and KNO3 is highly soluble in water. Those who are online, the condition for a salt to use in this salt bridge, ionic mobility of the cation should be nearly equal to the ionic mobility of the anion. So, a condition ka hisab se upon it is going to be Soumya. That's good. Well, nice. Okay, bachcho. Now we had a session now. In this session, we discussed just what is a galvanic cell, how this galvanic cell works. In this galvanic cell, we have seen anodic compartment, cathodic compartment, and various conditions. You can see anywhere in the galvanic cell, but the conditions of the external EMF and the driving force, and we introduced thermodynamics also. Sir, but I have a little, no problem. Anyways, we'll meet with more stuff in the next upcoming session where we can see various types of these single electrode potentials and electrochemical series, application of electrochemical series, and eventually we'll go into the electrolysis and Faraday's laws. This is nice question, Shauli Bhattacharya, and please like the session. Shauli Bhattacharya didn't like the session. Okay, when will be the next class? Day after tomorrow. Day after tomorrow, beta. You enjoyed class, Muhammad Affan? Right. So, Shauli, right, Soumya. I am done from my side, signing off. Suresh, Faculty of Chemistry from Infinity Lane. Please like this session, share with your friends, and subscribe to Infinity Lane Neet YouTube channel. Thank you. Thank you very much. Thank you. All the best. God bless you. We'll meet with more stuff in the next class. Stay tuned. Day after tomorrow, exactly 12 o'clock. Bye-bye.